So how fast are the seas really going to rise? It's one of the biggest, most important questions of our time. We know our coastlines are going to change, that's a given. But the real mystery, the big unknown, is how fast and by how much. And believe it or not, the answer to that trillion-dollar question is locked away in the ice at the very bottom of our planet, in Antarctica.
And look, this isn't some far-off, abstract problem for future generations. It's happening right now. What you're seeing here is the aftermath of Hurricane Florence, and it's a brutal reminder of just how vulnerable so many of us are. Think about this. Right now, some 230 million people around the world live on land that's less than a single meter above the current sea level. The stakes just don't get any higher.
And that brings us to the focus of this whole explainer, the West Antarctic Ice Sheet. Because if this one, uniquely fragile part of Antarctica were to completely melt, it holds enough ice to raise global sea levels by, get this, 5 meters. That's over 16 feet. Just let that sink in for a second. Okay, let's get one thing straight right off the bat. The seas are rising. That part is settled science. The real drama, the urgent debate that scientists are having right now, is all about the timeline. Are we talking about a slow-motion change over centuries, something we might have time to adapt to, or could this all happen much, much faster?
So what's the engine driving all of this? Well, it's heat. Our oceans have basically been acting like a giant sponge for the planet, soaking up over 90% of the extra warmth that's been trapped by greenhouse gases. And all that warm water isn't just sitting there. It's actively chewing away at the world's biggest ice sheets from the bottom up.
You know, our understanding of this threat has been moving at an absolutely breakneck speed. Way back in 1978, a scientist named John Mercer was already waving a red flag about West Antarctica. But then came 2002, and the Larsen B ice shelf just collapsed. It stunned everyone. Fast forward to 2014, and NASA confirms that parts of the ice sheet are now in what they call irreversible retreat. And then, in 2016, this radical new theory dropped, suggesting the whole thing could unravel way faster than anyone had ever imagined.
So why all the focus on West Antarctica? What makes it so special? Well, it has a hidden weakness, a kind of geological Achilles heel that basically makes it a ticking time bomb for every single coastline on Earth.
Okay, let's get our bearings for a second. We are talking about a truly colossal sheet of ice here. It's bigger than Alaska and Texas put together. On this map, you can see the glaciers that are really in the hot seat, like Thwaites and Pine Island. You can think of them as these giant frozen arteries, constantly draining ice from the heart of the continent straight out to sea.
And here is the absolute key to this whole story. Unlike Greenland or East Antarctica, where most of the ice sits on high ground, a huge part of West Antarctica rests in a giant bowl. And the bottom of that bowl is thousands of feet below sea level. And what does that mean? It means the warm ocean can get right underneath it and melt it from the inside out.
This brings us to what you could call the front line of this battle, a place called the grounding line. It's the exact spot where the glacier lifts off the seabed and starts to float. As that warmer ocean water sneaks in, it melts the ice right at that point, pushing the grounding line further and further inland, down into that even deeper bowl-shaped bedrock. This is the heart of the instability.
Now, this instability led to an absolute bombshell of a theory back in 2016, a real game changer. The idea was, what if this isn't a slow, predictable grind? What if it's more like a switch gets flipped and the whole thing just goes? A sudden runaway catastrophe.
And the crazy thing is, the spark for this terrifying new idea didn't come from a computer model. Nope. It came from something that happened in the real world. Back in 2002, an event that completely shocked the entire scientific community.
This is what they saw. You're looking at the Larsen B ice shelf, an area about the size of Rhode Island. And it didn't just slowly melt away, it shattered. It disintegrated into a slushy mess of icebergs in just over a month. And once that floating shelf, which was acting like a giant cork in a bottle, was gone, the glaciers behind it just took off. They started flowing up to 8 times faster towards the ocean.
Watching this happen gave birth to the theory of marine ice cliff instability, or MICI for short. The physics is actually pretty simple. Imagine an ice cliff taller than about 90 meters. That's around 300 feet. At that height, it just can't support its own weight, so it collapses. But here's the scary part. That collapse exposes a brand new, even taller cliff right behind it, which then collapses. You see where this is going. A terrifying runaway chain reaction. So when scientists took this new MICI process and plugged it into their computer models in 2016, The results were, well, they were alarming. They suggested that this runaway collapse could cause more than a meter of sea level rise from Antarctica alone by the end of this century. This didn't just change the conversation, it blew it wide open.
But hang on, science is always a debate. And right after this shocking theory was published, other scientists began to push back. They started asking, okay, wait a minute, is this runaway collapse really inevitable, or does nature have some built-in brakes that could slow things down?
And this right here is the core of the scientific tug-of-war. On one side, you have the accelerating force of MICI, where tall cliffs just keep collapsing. But on the other side, nature has its own stabilizing forces. For instance, as a glacier retreats, the ice behind it can actually stretch and thin, which would make the new cliffs shorter and therefore more stable.
So what are the main reasons for doubt? First, while the physics makes sense on paper, scientists have never actually observed this kind of huge runaway collapse in the real world. Critics also point out that as the ice thins and stretches, it should actually lower the height of the next cliff, preventing the chain reaction. And finally, all the rubble from a collapse can form a thick, icy slurry that might actually brace the cliff face, acting like a temporary shield.
And here's a truly wild card. The Earth itself can fight back. As the immense weight of the ice melts away, the bedrock underneath begins to rebound, rising up just like a memory foam mattress. Now, if the ice retreat is slow enough, this rebound could actually lift the grounding line, slowing down the invasion of that warm ocean water. It's a race between melting and geology. So, where does all this leave us? Well, it leaves us in a state of really deep and deeply important uncertainty. The science is still unsettled. We know the direction we're headed, but we just don't know the speed. This chart from the IPCC, the big global body of climate scientists, shows that uncertainty in action. Under current mainstream projections, we're looking at maybe 0.5 meter to 1 meter of total sea level rise by 2100. But, and it's a huge but, if the MICI theory is right, if a runaway collapse gets triggered, that could potentially double the high-end estimate to around 2 meters. That's the difference between a manageable crisis and a global catastrophe. You know, maybe the glaciologist Jeremy Basis puts it best, because he cuts right through all the scientific noise. He argues that debating the exact way it happens, slow grind or rapid collapse, can be a distraction from the fundamental truth. Either way, our coastlines are going to be radically different by the end of this century.
So we're left with this. The evidence is overwhelming that our world is changing and the ice is melting. The multi-trillion-dollar question that scientists are racing to answer isn't if our seas will rise. It's simply, how much time do we have left to prepare?